Hello viewers. Today we will be solving the IB Math EA HL November 2024 paper 2 question number 7. You will be getting the solutions for the first 6 questions of this paper and the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. I am Nilanjana Sanyal. I am an online IB Math EA HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question. The maximum marked is 6. A self-service sushi restaurant has a row of 12 available seats as shown in the following diagram. Anvi, Vanya and Parita decide to go to the restaurant for lunch. So part E's question is find the number of possible ways that they can be seated in this row if they decide not to sit together as a group of 3. Whenever you have this not something, in most of the cases, what do? We first of all find the number of ways, the total number of ways in which they can be arranged. This is a question of arrangement because whether Vanya is sitting before Anvi or sitting after Anvi is not the same. Okay, so it is arrangement. It is not just getting the seats. After we get the seats, we decide that these 3 people will be sitting on these 3 seats. Then comes the question, how will they be sitting? Okay, how will they be arranged in those 3 seats? So, first thing is we will be finding the total number of ways in which these 3 people can be seated. Okay, after we get the total number of ways in which they can be seated, we find the total number of ways in which they can be seated together and we subtract. That will be giving us the number of ways in which they are not sitting together. Okay, because not sitting together, A can be over here and V can be over here. A stands for Anvi and V for Vanita. They are not sitting together. And if instead of this seat, Vanita chooses this seat, also for this case, they are not sitting together. So how many distinct cases will you be taking one by one? It is better to check how many ways they can sit together and just subtract from the total number of ways in which they can be seated. Okay, so that is the usual custom of finding the number of ways in which something doesn't happen. Okay, there is a negation. So in most of the cases, we use this negation technique, subtracting technique rather. Okay. So total number of ways in which, let me write Anvi, E, Vanita V, and sorry, not Vanita, Vania. There is no I, sorry. It is Vania V and Parita P, in which E, V, and P can be seated will be equal to, there are 12 seats. So out of the 12 seats that are available, we need 3 of them. So it is 12C3. And after we grab 3 seats, there comes the arrangement questions. Where will each of these 3 people sit? Okay, so there is the arrangement which is 3 factorial. They can be arranged in 3 factorial ways. AVP, APV, VAP, VPA, and PAV and PVA. Okay, 3 factorial is 6. So it is 12C3 times 3 factorial, or you may write 12P3. I usually first of all select the C, so I use the C and then do the arrangement, so it is 3 factorial. Okay. Then number of ways in which they can sit together will be equal to, now it is together. So we can select these three, or these three, or this three, or these three, or these three, or these three, this one, this one, this one, and this one. How many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? So they can be selecting any of these 10 options, 3 consecutive seats. There are 10 options. Okay? So 10, any of the 10 possibilities can be chosen. And after they have selected the 3 consecutive seats, they can be arranged in 3 factorial ways. Okay? So now, therefore, the number of possible ways in which they do not sit together is equal to 12c3 times 3 factorial minus 10 times 3 factorial, equal to, we have to use the calculator. It is NCR 12, 3 minus, sorry, times 3 factorial minus 10 times 3 factorial. Okay, enter 1260. 1260 ways. The next day, Anvi, Vanya, and Parita are joined by 3 additional people in the same restaurant, and they sit in the same row of 12 available seats. Anvi, Vanya, and Parita now decide to sit next to each other as a group of 3. So part B's question is, find the number of possible ways that these 6 people can be seated. Okay. So let us start our answering. So part B. Now we have already calculated the number of ways in which these 3 people, Anvi, Vanya, and Parita, in which they can sit together. Okay, that was 10 times 3 factorial. So let us write that number of ways in which A, V, and P sit together is equal to 10 times 3 factorial. Okay, and there are 3 more people, additional people. So it is and, because they have to sit also. So out of the 12 seats that were available, 3 have been already taken up by these 3 people, A, V, and P. So there are 9 seats remaining. Okay. Therefore, 9 seats are remaining. And from those 9 seats, we have to get 3 seats for the 3 additional people. Okay. And number of ways in which the 3 additional people can be seated is equal to 9C3. From the 9 seats that are available, we have to first of all select 3 of them, and these 3 additional people can be arranged in 3 factorial ways on those 3 seats that we have selected. Okay. And these two are connected by this AND word. So these two will get multiplied. Okay. So it is therefore the total number of ways in which the 6 people can be seated is equal to this one, 10 times 3 factorial, and this one. And so multiplication 9C3, again you may write this as 9P3, okay, times 3 factorial. So this is equal to 10 times 3 factorial times NCR 9, 3 and times 3 factorial equal to 30240. 30240 ways. Okay. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you liked my explanation, and please do not forget to subscribe to my YouTube channel. It will be really motivating me, and it will be telling the YouTube that my video is worth watching. So the YouTube will be showing my video to more number of students. My video's reach will increase. This will be helping me a lot. And we meet again very soon in our next session. We'll be solving question number 8 of the same paper. Till then, bye.